Wolfenstein 3D was the first-person shooter released in 1992. It was a unique, fast-paced shooter that encouraged aggressive play and also featured 3D graphics that were not wireframe based. Though not the first 3D game, it did make it more popular. The reason I wanted to do this are a few. Firstly, finding out the different way of rendering 3D graphics while not really 3D is very unique. Secondly, it feels like the best example of not overscoping since the engine is limited. Let's start with the basics. The player character is what makes the game a game. He needs to move forward and back in the direction he is facing and strafe left and right. If you look at this from the top-down view and the player is facing right, moving in the x-axis is forward and back, while the y-axis is for right and left. We can do this by determining the values needed for moving given the angle with simple geometric equations and increasing the position incrementally. The green dot here is the player with the line showing the direction it is facing that can be now changed by moving the mouse. A level is what the player is going to move around in. In a basic way, it needs to have some sort of solid wall so that the game can be designed around it. This is where considering the layout to be a grid becomes advantageous. If you define a value as false and make the level using it and other characters in a 2D array fashion, the false value becomes the playable space and the number or alphabets become the walls. To make sure that we collide with the wall, we just have to run a check to see if the next tile is present as an empty tile or a wall tile. For this, we can send the array details to a dictionary where the keys are the coordinates. I gave some size to the player character so that it can collide properly and represented the walls as gray squares as seen here. But we need to make it a 3D game. That is the beauty of the Raycasting engine. It's not actually 3D where the z-axis is involved, but rather the walls are projected in 3D perspective. That is why in those types of games you could not look up or down. For this, we first need to use a raycast. Think of it as a line shot in a direction and can return information if it has collided with anything. In our case, we can determine the distance to that object since we have the entire game on a grid. We can consider that each tile is 1 unit each. So if we were to consider the intersection happening in both horizontal or vertical lines with the raycast, at least one side will be fixed. Then using that along with the wall collision code, we can have it stop when a wall is in the way. Repeat this some 20 times and we have a working code of vision. Next we calculate the projection height using the distance math and simply draw them to the screen. I added a few extra things like for example darkening the farther walls and removing the fishbowl effect, which happens because we are using the Cartesian coordinate system with the polar one. Then I added a few other things like an enemy class, health, score, and finally the victory and defeat end cards. All of them will be working independently, of course. Then it is time for texturing the walls. For this, we first start by loading the textures in the correct resolution. Next we create a dictionary for each of these textures so that we build the level by using them to represent the different walls. Then we need to do is split the texture into equally sized slices such as we can project them by offset based on the player view. Then we just need to do some optimization to clamp the height value and we have walls. The sky can be drawn on the top half of the screen and the floor color can be set to the bottom half of the screen and rotate to the player's camera. Since all of the walls are being drawn on top of them, we'll have a decent looking sky and floor. We need to draw the gun and the reticle in the player's view such that it moves with the camera. We then add sound effects and animate it. I'm not going to explain this one because it's been done hundreds of times before and it's kinda tedious. Then we can inherit it to make an animated sprite that can animate on its own. This is what we'll use for the enemies and some props in the level. We can then add the billboard effect, basically means the sprite will face the character. Finally, we can add the enemies. The basic system involves keeping track of the player's position and chasing them. There are two problems with this approach that need to be addressed. First, we can't have the enemies chase the player without them seeing the player first, as it won't be fair. Next one we need to fix is that if there is a wall in the way, the enemy will get stuck at the wall. Let's fix the line of sight first. We can use the same raycasting code, only now it needs to see if a player is detected. We can further enhance it to chase till a distance and shoot from there. We can also apply this logic to both player and the enemy to ensure that they don't shoot through the walls. We need to have some sort of pathfinding to make sure the enemy knows how to navigate to the player. For this, we will use graphs. In computer science, a graph is an abstract data type that is meant to implement undirected graph and directed graph concepts from the field of graph theory within mathematics. That is not helpful at all. It's basically a collection of nodes that can be connected to represent a complex relation. We can start at the enemy's tile as the root node and then check all of the surrounding nodes if it is possible to traverse. Then we use breadth first search or BFS for short to traverse the tiles till we reach the player. Thus we can find the path to the player. I've also added some extra checks to make sure that the two enemies are not in the same tile, and here is the result of that. The only thing left to add is the UI, main menu and music I stole from the YouTube. After all of that, we can start making levels and add a few enemy types. Now, let's see some high octane gameplay. This project was a lot of fun. During the fun part, the level making and enemy positioning did get tedious, but I learned a lot from it. To see the trailer, click here. That's all for now. Like and subscribe for more dumb stuff, and see you on the next one.